Okay, hi Danny, welcome to lesson number 61. In this lesson, you're going to start out doing 90 division facts. Okay, so get out your division facts and I'm going to put a timer on. You ready? On your mark, get set, go. That's about a minute. You're doing awesome. Keep going. Good job. That's 2 minutes. That's about 3 minutes. You're doing awesome. Keep going. Okay, that's about 4 minutes. Don't worry if you don't get them all done. Almost there. All right, we're going to stop it right there. Good job. Let's go back to the lesson. Okay, this is going to be awesome, Danny. This is a great lesson. We're going to talk about the remaining fraction and also two-step equations. So this is really great. This is going to be super fun. First, let's go over this comic. This is Before Paper and Scissors. So that's the title of this. Before papers and scissors were invented, right? Because it looks like these guys are cavemen. So this guy's saying, dang, tight again. Ready? 1, 2, 3. What do you think they're doing? I think they're playing rock, paper, scissors. But papers and scissors weren't invented, so they just keep tying, right? That's pretty silly, isn't it? All right, let's go on to mental math. For mental math, we're going to first do multiples of multiply by 10. We're going to multiply by 10. Okay, I gave you some beautiful pictures to look at while we do this. 12 times 10, write your answer. B is going to be 120 times 10, write your answer. One way you can think about it is just like adding an extra 0 when you multiply by 10. Let's do C. 10 times 10. What is your answer? Okay, D, we're going to do 48 plus 250. E is going to be $1 minus 36 cents. You remember how to do those? This has to add up to 10. This has to add up to 9, right? Okay. All right, what about F? We're going to do $3.75 plus $3.75. All righty, let's move on to problem solving. Problem solving wants to know, this whole circle has been divided into quarters. That means there's 1 quarter here, 1 quarter here. It means a quarter as in like 1/4 is 1 quarter of something. So it's been divided into quarters. What percent of the circle is darkly shaded? So this is where I put the darkly shaded one. What percent is darkly shaded? So write your answer. And then it wants to know what percent is lightly shaded, like these. What percent? So if you had to pick a percent, what do you think it would be? All right, I'll let you figure that out, and we're going to move on to the new concept, okay? And there's a dog learning a new thing. It looks like he's learning to ride a bike. That's pretty cool. All right, for our new concept, this talks about remaining fraction. So what's left over of a fraction? So the circle, kind of like in the problem solving exercise, where it had a darkly shaded portion and then it had a lightly shaded portion. And it turns out if you know the size of one portion, so it's a part of a whole, then you can figure out the size of the other part without doing too much work. So, for example, this wants to know what fraction of this circle is shaded. So the first thing that we have to do is to figure out how many parts has it been divided into. So I'm going to count. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8. So I know that the denominator, or the number on the bottom, is going to be 8. And what number goes on top? The number that goes on top is the number that is shaded. So it's going to be 1, 2, 3. So 3 out of 8 is shaded. And then it wants to know what fraction is not shaded. So that's the next part. And I still put an 8 on the bottom because that's how many pieces it's divided into. And then how many is not shaded would be 1, 2, 3, 4, 5. So it would be 5 out of 8. But there's an easier way to do it because if you know what fraction is shaded, you can easily figure out what fraction is not shaded even without counting like that. And that's what we're going to go over in a little while, okay? So let's do example 2 first. Example 2 says there's a pizza and it's cut into 8 equal slices. Okay, so I'm going to take this pizza and I'm going to cut it into 8 slices. Let's see if I can do it. First, I'm going to draw a circle around it. Okay, so it's like that. And then I'm going to go, let's see, I'm going to put a line down the middle. I'm going to slice it down the middle. Okay. And then I'm going to go, and then I'm going to slice it like this. So now it's in 4 pieces, but I want it in 8 pieces. So then I'm going to cut each piece in half again. And I think that is going to, whoops, I wanted that to be straight. Let's see if I can get it straight. There we go. I think that'll give me 8 pieces. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Yay, I did it. So it's cut into 8 slices. Now, it says, after Willis, Tony, and Jenny, I got a slice, took a slice. What fraction of the pizza is left? All right, so let's figure this out. I'm going to take my white, and I'm going to say, all right, Willis took a slice, so maybe he took this slice. And I'm going to color it in so it's gone. It's gone. That slice is gone. Okay, Willis took a slice, so that's his slice. Now Tony's going to take a slice. Maybe Tony takes this slice. Okay, so Tony takes this slice. And then Jenny takes a slice. You know what I should do, though, is I should keep this so that it's easier to see how many slices are gone. Okay, I'll do that. And now Jenny's going to take a slice. So I'm going to take this slice. And this slice, I'm going to eat it. It's delicious. Ooh, that's delicious. Okay. Now, what fraction is left over? So I'm going to make a fraction. The number that goes on the bottom of the fraction is the total number of slices, even the ones that are gone. And I know I cut it into 8 pieces. Let's double check again. 1, 2, 3, 4, 5, 6, 7, 8. Yep, so I'm going to put an 8 on the bottom. How many is left over out of the 8? 1, 2, 3, 4, 5. So 5 out of 8 pieces is left over. Okay, easy peasy, right? You're like, this is easy. I got it. The way to figure out how many was eaten without counting, what you do is you know that you started out with 8 out of 8 pieces. So you just subtract the 5 out of 8. And when you subtract 8, 8 minus 5, 8, you're going to end up with 3 eighths, and that's how many got eaten, 3 out of 8. The denominator stays the same when you subtract fractions. Let's do another example. Example 3. See how everybody's cheering in this picture? This is from Apollo 13. You probably recognize that. This is a word problem about cheering, so that's why I put that. In this word problem, it says, 2/5 of the crowd cheered. What fraction of the crowd did not cheer? Okay, so we're going to think about a crowd like as if they're in a big gymnasium or something, or a big like stadium, okay? And then I'm going to divide that stadium into 5 equal parts because it says 2/5 cheered. Okay, so I'm going to divide it into 5 parts. So that's 1, 2, 3, 4, 5. So are there 5 parts? 1, 2, 3, 4, 5. Okay, so 2/5 cheered. So if I had to color that in, I would do like this group cheered, this group cheered, okay. And then it wants to know how many did not cheer. So this group did not cheer, this did not cheer, this did not cheer. So the people that did not cheer are 3. I'm going to get a different color so it's not confusing. Did not cheer, did not cheer, did not cheer. So this is 3 out of 5. No cheer. They were not cheery. Okay, so the answer is 3/5. Let's make that a little easier to read. 3/5. That's not easier to read, is it? 3/5? No. Let's just say 3/5 did not cheer. Okay. Now we're going to move on to 2-step equations. This is going to be really fun because we're going to get something that looks really complicated like this. This looks like Zach's homework to me. Man, whew, this is hard. So in this equation, we need to find out what the number is for n. What is n? Well, it's not obvious when you first look at this equation what the number is for n. So the first thing that we have to do is add these two together. And when we add these two together, it'll become easier to see. Okay? So let's try it. We're going to say 2n is equal to, and then we're going to add this together. Now you don't have to draw that. I'm just doing it to show you. So 7, 8, 9, 10, 11, 12. 7 plus 5 is 12. And now this is back to something that you're used to seeing. 2n is equal to 12. So n times, or 2 times what is going to be equal to 12? And then I think you know that n is equal to 6. The way you figure it out is to do the inverse operation. So 12 divided by 2 will give you the answer. Like that, 12 divided by 2. Okay, and the answer is n equals 6. Let's do another one. This is example 4. Dun, dun, dun. Okay, here we go. Example 4 is 3m equals 4 times 6. Now that dot means times. It's the same as doing times. So the first thing that we need to do is solve this part of the equation. So let's do that. It's going to be 3m equals, what is 4 times 6? 4 times 6 is 24. Now, 3 times what is equal to 24? And if you don't know it right off the top of your head, the way to figure it out is to do the inverse operation. What is 24 divided by 3? And then m is going to be equal to 24 divided by 3. So I think you can figure out that m is equal to 8, because 8 times 3 is 24. Perfect, perfect. And that is it for the lesson. And, you know, a lot of times you're going to get really complicated equations that look like that, and you're going to have to simplify it. So here's a kid right here asking, wouldn't it be more efficient to just find out who's complicating equations and ask them to stop? Yeah, maybe that would be easier, but it's not funner because it's fun to do these math problems. It's like solving a little mystery. All right, Danny, good luck with your homework today. Have fun doing your math. Love ya. Bye.